Welcome back into our next video here, continuing onward with our next couple of examples for finding function values in the difference quotient, which these are going to definitely be on the test. Let's say we're given a function denoted as f of x is equal to 2x squared plus 3x, and they're going to ask us to evaluate. So what's going to happen here is that they're going to give you an x value. Now, it's not going to be like the previous examples when they say x is this value, find the y. What they're going to give us for a part A is find f of 3. Notice that f parentheses 3, the 3 is in the x position. So every place you see an x on the right side of the equal sign, you're going to put a set of parentheses around it, each x, and you're going to plug the 3 in its place. And now you simplify this expression. So 3 squared is 9. 3 times 3 is 9. 2 times 9 is 18. We'll add the 9 to that. We get 27. So f of 3 is equal to 27, which again is like the point 3 comma 27. The x was coordinate is 3, the y coordinate is 27. That's our point 327. B, find f of 3 plus f of x. Well, all they did was add an f of x to this problem. So if, again, you substitute the 3, that's what we did earlier. So I'm not going to redo this work, and I don't expect you to as well. You can just call that 27. But then this plus f of x, this is its own separate function, so I put it in its own set of brackets. So each set of brackets here is representing these function notations. All right, so we know this one was 27. And the function being is in the parentheses or a grouping symbol. All this has to be done first before you can add the second function to it. Now, 2x squared plus 3x, we're not putting a 3 in for this x over here because that's just f of x. There's no value there. So the x's stay. So we combine like terms if possible, but that's not possible. So we'll just add 27 to the end of this expression. One of the things you will notice in my math lab is they'll probably tell you next to the text box, write your answer in descending order of powers on your variable. So we'll put the 27 at the end. Next example, 3 times. Now this is like 3f, 3 times f, 3 times f of x. So again, f of x, just like the previous problem, we put brackets around the 2x squared plus 3x, and we'll put a 3 times in front of the brackets. Well, that's the distributive property to us. Take the 3, we'll distribute it into the 2x squared, take the 3, multiply to the 3x, and you come up with 6x squared plus 9x. So 3 times f of x is this expression, 6x squared plus 9x. Again, if x is in the parentheses, x has to be in your answer. As in part A, when they put 3 in the parentheses, you put 3 in and you come back with a number, no x's. Part D, find f of negative x. All right, just like we did in part A, you put 3 in for all the x's. In this case, we put parentheses around all our x's and we put a negative x into each one and then simplify. So a negative x being squared. A negative x times a negative x is a positive x squared being multiplied to my 2. So technically this is like the same term, 2x squared. But a positive 3 times a negative x is a negative 3x or minus 3x. So since that x is to an odd power, then the sign will change when you plug in a negative x or a negative value. If your powers are even, they'll still be positive. Part E, negative f of x. Well, this is really a negative 1 being multiplied to my f of x. So just like we had with the example 3 times f of x, we multiplied by 3 to the front, we'll just multiply by a negative 1. Distribute the negative 1, and that's just going to change the signs of all your terms. So negative f of x equals negative 2x squared minus 3x. Example part F, f of 3x. All right, just like we did up in D, parentheses around all my x's, but now we're going to put a 3x inside all my parentheses, and we'll simplify accordingly. So 3 squared is 9, x squared is x, so this becomes 9x squared. 3 times 3x, this becomes plus 9x. This 9x squared in the parentheses will be multiplied by the 2, so 2 times 9 will make that 18x squared. And there's my f of 3x. It's equal to 18x squared plus 9x. Part G, f of x plus 3. Okay, this, hold it, is a little different than 3x. 3x was technically one term. Now, x plus 3, that's two terms. This is a binomial going to be substituted in for every x. This is where you need to slow down. When you want to square a binomial, you should write it out twice and FOIL it. X times x is x squared, that's the f. X times 3, there's the 3x, that's the O, the outer terms. 3 times x, that's the inner two terms, that's I. 3 times 3 is the plus 9. This 3 here gets distributed to the x plus 3. So 3x, and the 3 times 3 is 9. Now, at this point, it's optional. You can combine these two terms first, then distribute the 2, or you can distribute the 2 and then combine all like terms. I opted to just double all these numbers. So 2x squared plus 6x plus 6x plus 18. And now I'll combine all my like terms. So 6x plus 6x plus 3x is the 15x. 18 plus the 9, those are my constants, that's 27. There was no other x squared term, so I leave that out in front. Example H. Evaluate f of x plus h minus f of x all over h, where h does not equal 0. Okay, put a little note next to this problem. Asterisk, this is definitely on the test. This is known as the difference quotient. It's a test question. All right? It's kind of like a formula. You want to memorize this. Doesn't matter if they give you g of x or h of x. It's f of x plus h minus f of x all over h. Now, why is there h cannot equal to be 0? Because you can't have 0 in the denominator. That would be an undefined value. So what we want to do here is very similar to what we did in the previous problem. This is a binomial. We're going to simplify everything on the top first. And we'll bring the h in once all the parentheses and grouping symbols are gone and we've combined like terms. So bracket around the first function, bracket around the second function. So 2 around this x, I put in the x plus h being squared, plus 3 times this x. So x plus h goes into those two x's right there. Minus brackets around f of x. Well, we already know what f of x is. It's 2x squared plus 3x. We can distribute this sign right away. We can write this out twice to prepare to FOIL it. We've got rid of the brackets on the first function because nothing was being multiplied to it. Once you distribute the minus sign, very important, don't forget that. You don't need the brackets. Now we get rid of the parentheses. So I'm going to FOIL these two and distribute the 3. So x times x is x squared. X times h is xh. Plus h times x is another xh or hx. So there's 2 of those. Remember, when you FOIL, the 2 middle terms can combine together. And h times h is h squared. There's my 3 distributed to both of those terms. Now the green parentheses are gone. Now we just have to get rid of these last set of parentheses. That was our goal, to simplify the top where there's no grouping symbols and everything is combined together. So I'll distribute the 2, 2x squared plus 4hx plus 2h squared, plus 3x plus 3h minus 2x squared minus 3x. Now, once the parentheses are all gone, here's the key. Where you change the signs on that minus f of x function, all the terms that do not have an h in it must cancel. So here's a positive 2x squared, here's a minus 2x squared. They're opposites, they cancel out. Has an h, has an h. Oh, here's a plus 3x, there's a minus 3x. Those are all gone. So what I'm left with is 2h squared plus 4xh plus 3h. I could not combine those 3 terms. And it doesn't matter what order you put these terms in. Now that the top is all completely simplified, now I bring my denominator of h back in. And notice that all 3 terms have an h in it, so I can factor an h out of the top as a GCF. So 1h from the h squared comes out front. That leaves me 2h. This h is divided out front. This h is divided out front. And now that that GCF of h is out front, this h and this h, they can cancel out. And you're left with 2h plus 4x plus 3. That is the answer to the difference quotient. You need to know these steps. Practice them well. This is on the test, and it's worth a lot of points because there's a lot of steps to be done. All right, so again, remember, on the test, memorize it, write it in your notes. This is our second video for section 3.1.